right, this is a re-quiz review, and these are the identities, problems 1 through 8, that we had on your original quiz. The first one, cotangent of theta times secant theta. All right, we want to change everything to sines and cosines. So I have cosine theta over sine theta times secant theta, which is 1 over cosine. When I multiply fractions, I can reduce. I'm left with 1 over sine theta, which I accepted that. And we know that that is cosecant of theta. All right? Problem number 3. You have cosecant theta plus 1 times cosecant theta minus 1. I recognize that as being the difference of two squares. And if I use FOIL here, I'm going to get cosecant squared theta minus 1. If you had that on your quiz, I gave you credit. I was pretty lenient on that one. If you think that that is an identity, that is one of your Pythagorean identities, and what this equals is cotangent squared theta. If you remember the one identity, cotangent squared theta plus 1 equals cosecant squared theta. And so cotangent squared theta equals cosecant squared theta minus 1. Problem number 3. Oh, I skipped 2, didn't I? Number 2. Secant theta over cosecant. Secant is 1 over cosine divided by cosecant, which is 1 over sine. When you multiply fractions, we multiply by the reciprocal of the divisor, or we flip the second one and multiply. One times sine theta is sine theta. Cosine theta times 1 is cosine theta. Right is one trig function. What's sine over cosine? Tangent. All right. All right. Problem number 4. Tangent squared theta plus 1 times cosine theta. And I think these things are easier than what you think, because if you recognize that this is also a Pythagorean identity, this equals secant squared theta times cosine theta. Secant, I know, is 1 over cosine squared times cosine, and I can reduce. I'm left with 1 over cosine, which is secant theta. Number 5. I didn't like this problem, but it was simple. Because the directions say write each expression in terms of a single trig function, and it's kind of in terms of a single trig function. It's in terms of sine. But if you look at that bottom, at the denominator, you have sine squared theta over, and that's a Pythagorean identity, It's over cosine squared. Sine squared over cosine squared is tangent squared. Number 6. Cosine squared plus sine squared over, we know that's 1, over secant times cotangent. Sine squared plus cosine squared is 1. Over secant is 1 over cosine times cosine over sine, because that's what cotangent is. The cosines will reduce, and what I'm left with is 1 over sine, or 1 over secant, which I accepted. Does that make sense? 1 over sine is 1 over, actually it's 1 over cosecant. Or you can just simply write sine theta. Number 7. Secant squared theta minus 1 over tangent theta. We have another Pythagorean identity on top. Secant squared theta minus 1 is tangent squared theta over tangent theta. Reduce it, tangent theta. And finally, number 8, you have cosine over sine times cotangent. Cotangent is cosine over sine. The two sines will cancel out. I'm left with cosine over cosine, which is 1. Okay? So that is your 8 identities on the second page of your quiz. And we went over the answers on the first part. And I think, did I tell this class that I think your re-quiz is going to be on Thursday? Yes. Okay. So we'll be on Thursday. All right.